Hello everyone, my name is Ray, who is in charge of technical service. Today, I'm going to introduce you the basic knowledge of Ethernet, the Ethernet essentials. To start this course, there is no need for any basic knowledge. In this course, I will introduce you the basic knowledge of Ethernet network for you to learn OSI NPort products. In this lesson, you will learn three things. The first one is what a network is and how to define a network. The second part, I will introduce you the OSI 7-layer model. This model is a very important model for you to learn in protocols. The last part is the essentials of Ethernet network. Today's agenda is separated to three parts. As you know, the word network becomes very popular in recent years. But what is network? This is the first section I would like to tell you. The second part is a very useful tool when learning new protocols. In all this course, we will always start learning protocols based on the OSI 7-layer model. And the last part, I'm going to introduce in the Ethernet essentials from physical layer to MAC layer, and the technology and the device of Ethernet network. Let's start with what network is. Networking is the practice of linking computing devices together with hardware and software that supports data communications across these devices. And why we need it? Network provides these benefits. Information sharing. All the documents on a PC can be shared via network to another PC, which means another person can read it easily. Resource sharing. For example, a printer connected to PC A can be used by PC B via network. Cost saving. Follow the example of resource sharing. You don't have to buy two printers for PC A and PC B. You only need to buy one printer and share it with all network that every PC in this network can use it. It saves money. Improve management. Since you can connect all the devices together by network, you can manage all these devices by a central system which helps you to save resource and time. These four benefits makes network everywhere now, in most cases. We want everything to go on network. Here are several popular networks. They are separate as different kinds of network based on the coverage of that technology. From big to small of the coverage is WAN, wide area network, bigger than 50 kilometers. MAN, metropolitan area network. The coverage is around couple kilometers. LAN, local area network, less than 1 kilometers. And PAN, personal area network, less than 10 meters. For the wired networks, the most famous is Ethernet. This is also today's topic, and I will introduce it in the following slides. Other technologies may be used as a backbone, which is not today's topic. And about the wireless networks, we may introduce them in different courses. As I mentioned, the network is used for connecting different devices. These devices may be made by different vendors and different systems or different structure. So, how to connect them together and communicate with each other? The ISO, International Organization for Standardization, define an open standard protocol for solving this issue, and which I will introduce in the following slides. Let's start about what OSI 7-layer model is. The OSI 7-layer model is defined by ISO. It divides the function into a series of layers. Each layer only uses below layer functions and only services to above layer, which make it easier when implementing a protocol. And since it's defined by ISO, it's an open standard, and it divides functions as layers, it's easier to be integrated and easily adapt to a new technology. For the following slides, I will introduce it from bottom to top, one by one. Layer 1 is physical layer. As its name, Layer 1 defines the electrical and the physical specifications, how the hardware establishes connection to a communication medium. For example, the RS-232 is a serial interface and the 100 base T is an Ethernet interface. Layer 2 is data link layer. It ensures data correctly transferred between nodes, which means it defines how to transfer the data to prevent collision or what to do when collision happens. There are two sublayers of data link layer, LLC, Logic Link Control Sublayer, and MAC, Media Access Control Sublayer. The layer 3 is network layer. It determines how data is transferred between networks, includes address mapping, routing, segmentation, and desegmentation. A famous protocol of network layer is IP, Internet Protocol. Transport layer is the fourth layer. It ensures data to be sent correctly from end to end. Layer 4 defines if the protocol builds a connection before sending data. Does it need flow control? Or, when error happens, how to recover it? Two famous protocols are TCP and UDP. The session layer controls the dialogues between computers. It establishes, manages, and terminates the connections between the local and remote applications. An example is PPTP, Point-to-Point Tunneling Protocol, a method for implementing virtual private networks. PPTP uses a control channel over TCP and a GRE tunnel operating to encapsulate PPP packets. This layer provides independence from data representation by translating between application and the network formats. The presentation layer transforms data into the form that the application accepts. This layer formats and encrypts data to be sent across a network. For example, the SSL secure socket layer will encrypt the data from application layer and decrypt the data from session layer. The application layer is the OSI layers closest to the end user, which means that both the OSI application layer and the user interact directly with the software application. This layer interacts with software applications that implement a communicating component. For some examples, FTP, File Transfer Protocol, SMTP, Simple Mail Transfer Protocol, and Telnet. After you know the 7 layers, this slide explains how they work. From sender to receiver, the original data is generated by application layer and passed it to the below layer presentation. The presentation layer will add header to the data, then pass it to the next layer, session layer. Follow this rule one by one. Each layer will add its header, which we'll call encap, then pass the new data packet to below layer until the physical layer. It will send the data on the network. When the receiver receives the data, each layer will decap the data, remove the header added by the same layer on the sender, then pass to the above layer. Finally, the application layer can get the original data. After learning the OSI model, let's base on it to learn a new technology, the Ethernet. Let's start the last part of this lesson. What Ethernet is. The Ethernet protocol is defined in IEEE 802.3. The IEEE means Institute of Electrical and Electronics Engineers. It's a professional association headquartered in New York City that is dedicated to advancing technological innovation and excellence. It has about 425,000 members in about 160 countries, slightly less than half of whom reside in the United States. The Ethernet is a Layer 2 protocol. The physical layer defines the interfaces it supports, and the MAC sublayer defines how to transfer the data and what to do when collision happens, which is called CSMACD. The history is as the slide shows. You can see in the beginning, the bandwidth is only 10 megabits per second. In 1995, it reaches 100 megabits per second, and now it's more than 10 gigabits per second. In the following slides, I will introduce it from physical layer to MAC sublayer. The most popular interface of Ethernet is twisted pair coupled cable. There are two major kinds, unshared UTP and shared STP cables. A shared cable can prevent electromagnetic interference. There are different categories of the cable. A Cat5e cable is the most popular cable for 100 megabits per second Ethernet network, and Category 6 cable may use for 1 gigabit per second. All these cables can only connect two devices in 100 meters. If it needs longer, you may need a repeater to regenerate the signal. Next slide, I will introduce the connector of these cables. The most popular connector is RJ45. You can easily find it on your PC. In some specified environment, maybe on a train or some industrial environment, you may see a connector called M12. The M12 connector can reduce the wiring time and the vibration interference. The pin assignment of a RJ45 connector is as below. Because all the PC may have the same pin assignment, you may need a cross cable to connect two PCs. To make it easier, most cables now on the market has the MDI/MDIX auto crossover feature for user to connect PC with PC or PC with other devices, such as hub or switch. The CSMACD means Carrier Sense Multiple Access with Collision Detect. The keyword is collision detect. When a node wants to send data, it will listen if there is any node sending data first. If not, it will send data out. If there is another node sends data out later, there will be a collision. Both the nodes will find out that there is a collision on the Ethernet network. So, they will wait for a random time, then try again. If a collision happens again, they wait for another random time again and again until the data is sent out successfully. The MAC sublayer. There is another important thing I am going to introduce. The MAC address. Every network device has a MAC address, just like your home address for a postman to give you a mail. The MAC address is the same idea. Every device has a unique MAC address with 6 bytes long. The first 3 bytes is the vendor ID. You can distinguish who made the device by the vendor ID. For example, Mosa is 00 90E8. When you see a device with this vendor ID, you know it's made by MOSA. The last 3 bytes is assigned by the vendor. When a node is going to send data out, it will put its MAC address as the source address, and the target node's MAC address as the destination address. Just like you write down your friend's address as addressing your own address as the sender for a port name to send the mail. There are different traffic types, and let's explain it in the next slide. There are 3 kinds of traffic types: unicast, multicast, and broadcast. Unicast is just as I said, when the data is sent by one node to the other. The sender will put its own MAC as source and the others as destination, then send the data out. If the node wants to send the information to multiple nodes, it will fill the multicast address in the destination address. How to distinguish a MAC address is a multicast? A multicast MAC address, the lowest bit of the first byte should be 1. And if the data is going to send to every node on the network, the MAC address should be all 6 bytes of FF. After talking about the physical layer and the MAC sublayer of Ethernet, there are 2 related ideas I would like to introduce here. The first one is the Ethernet topologies. In the beginning, the Ethernet network may use bus topology. Every device connects to the Ethernet network like daisy chain in a serial network. In this case, if there is one device down, the entire network is crushed and hardly to find where the error is. Now, in most IT environment, may use star. All the network devices will connect to a switch or hub in the middle, and if there is one down, others can keep working and easily to find which one is offline. The third topology is ring. It's popular in industrial environment since it has backup place for redundant. The second thing is the comparison of 2 devices, a hub and a switch. A hub is just a repeater. It's a layer 1 device. A switch, it may be a layer 2 switch or a layer 3 switch. But the major difference between them is how they handle the Ethernet traffics. When the data comes in from one port, a hub will forward it to all ports. But for a switch, it will just forward it to a specified port. After today's introduction, there are 4 things to remember. First, the OSI 7-layer model is defined by ISO, and each layer only uses below layer functions and services the above layer. Second, the Ethernet is the layer 2 protocol. Third, the CSMA-CD is the collision detection mechanism to help the node to send data out. And the last thing is the comparison sheet between the hub and the switch, which may be easily to be mixed while discussing cases with the customer. Thank you for your time, and this is all I would like to introduce.